Hello everyone, welcome to the channel Vidya. In this video, we'll see the demonstration of design and simulation of DC machine using ANSYS Maxwell software, that is RMXprt tool. In case if you have not subscribed to this channel, please do subscribe so that you will get the updates about latest video. So without wasting time, we'll start the demonstration of a design and simulation of a DC machine. So those who are new to this channel, please go to the video related to the introduction to the RMXprt tool, which is uploaded under this channel only. So till now we had discussed that whenever we are going to do the design of any machine using ANSYS Maxwell software, then we need to go through the certain steps. So for this DC machine, first of all, we need to insert RMXprt design. Then we have to select the type of the machine, that is for this case DC machine, as per the design requirement. Then as per your convenience, you can rename the project. Then you need to provide the inputs which are needed to design the geometry of selected motor like DC machine. Then you need to add the solution setup. Then we need to analyze all the design, so that if there is any error, then that error will be pop up and we need to rectify that error. And then we need to validate the design. So what is the meaning of validate the design? That means if there is any parameter which is not within the acceptable limit or which is not as per the design standard, then it will shows with red color cross mark, and then we need to rectify that error. And once our design is validated, then we need to right click on the setup, and then we'll get the detailed design sheet. Then we can download that design sheet, or you can go through the different performance characteristics of the motor to confirm that your design is fulfilling the requirement of your application for which you are going to design the motor. Okay, so these are the general steps. Now we'll go to the software directly. So we know that whenever we open the ANSYS Maxwell RMXprt design, then there is first step, that is insert RMXprt design. So here insert RMXprt design symbol is given. So when you click on that, then you will get idea about different type of the machines or motors which you can design with the help of this ANSYS Maxwell RMXprt tool. So what are those type of the machines? Like adjust speed synchronous machine, brushless permanent magnet DC motor, then clock pole alternator, DC machine, generate rotating machine, then line start permanent magnet synchronous motor, permanent magnet DC motor, single phase induction motor, switch reluctance motor, then 3-phase induction motor, 3-phase non-silent synchronous machine, 3-phase synchronous machine, universal motor, etc. That means this list shows that you can design and analyze the conventional motor as well as special purpose machines. Okay, so for this case, we are going to design the DC machine. So you can click on the DC machine and then you can enter OK. So once we enter the OK, then such type of the project will be available on the left hand side. Okay, but if it is not visible, just make sure that under the view option you need to select the project manager. Okay, and status bar, that is when we do the analysis, that status will be shown here in downward direction, that is show progress. So if the project manager box is unchecked, then this it will not be visible. So make sure that before starting the project you need to click on the project manager. Now once we click on the project manager, then here if we you can rename your project as per your convenience. So here just click on the rename and give the name. Right now just I am clicking the name same like RMXprt design 1. Once you rename the project, then what you need to do, you need to just click on this plus button. Just a minute. you just need to click on this plus button so that the different sub menus will be available. So here now you need to follow the third step, that is you need to enter the design input for making the geometry of this DC machine. So for that purpose, what you need to do, you just click on the plus button, then there will be sub menus like stator, rotor, commutator, shaft. That means we need to give the design input for all these sub parts of the motor so that entire geometry will be available. Okay, so what are the and then under the stator also, what are the constructional part of the DC machine like pole, field. Then under the rotor there are slots, rotor winding, commutator. Then you can check or uncheck the shaft, and then your machine geometry will be created. Okay, so for this purpose I will just select the one project in which I have already given the design input so that it will be easy to cover this content within the time. So for example, we have selected this machine and I have renamed the project as Z_500 DC machine. So 500 means I have selected the project of 5 kilowatt DC machine. So when I double click on the machine for giving the design input, then these are the inputs needed, like machine type. So machine type is the DC machine. Obviously we have selected this type of the machine. Then number of poles. So here the name of the parameters which are needed as an input to make the geometry of the machine are given on the left hand side. Here we need to enter the values as per our theoretical design. Mostly the general procedure is that once you get the total idea about the machine, then whenever you are going to design the machine, you should have the idea about all the basic technical parameters along with their meanings. Then it will be better if you do the theoretical design first for any machine, and then you need to give the input of, as an input those theoretical design values here, so that you will get the idea about performance of that machine. Then if you are not having idea about any parameter, then under the description option the meaning of that parameter is also given. Okay, then regarding the units, here you are having the different options for the unit, like for the frictional loss there are the different units. Okay, list of the different units. So as per your convenience you can select the unit and you can give the input. Okay, so under the machine option, what are the parameters we need to give as an input? So first one, number of poles. So what is the meaning of number of poles? So here if you just drag the cursor here, it will give the meaning, that is number of poles of the machine. So here we have selected the 4-pole DC machine. Frictional loss. What is the meaning of frictional loss? The frictional loss measured at the reference speed. So here right now we'll consider it will be 0. Then windage loss, here with windage loss measured at the reference speed, here also we have considered 0 watt. But as per your design, as per the permissible value of the frictional and windage loss, you can give the input. Then reference speed means the reference speed at which the frictional and windage losses are measured. Here we have considered 1080.51 RPM. So you can give the input as per your design requirement, and then you need to enter the apply button. Okay, for example, suppose here value is given like 1080.1. then when we enter the new value, then that apply button will be activated. Just enter on it and then enter OK. So we have given the inputs related to the machine here. Then next point is, when we click on this machine plus button, then it will show the sub menus of the machine like stator, rotor, commutator, shaft, etc. So when we double click on the stator, then it will ask for the inputs related to the stator design. So what are the stator design parameters? like frame outer diameter. Okay, what is the meaning of frame outer diameter? Frame outer diameter or maximum diameter for polygon type of frame. So here we have given the input as 760 mm. Okay, again here there are the options for units. Then frame overall width. What is the meaning of frame overall width? That is minimum outer width for a polygon type frame. So here I have given the input of 760 mm. Then frame thickness. What is the meaning of frame thickness? So thickness of that frame, it is given in mm. So here I have given the input as 51 mm. Then frame length. Frame length is given 671.3 mm. Then frame material, that is material which is required to prepare the frame. So for this purpose, if we double click here, then you are having the material library list. So just wait till the material library will be available. But in case of the material library, there is a list of the different materials. So this is the beauty of this software, that you can select any material from the available list and you can check the performance. Otherwise, you can compare the same design with the help of the by using the different material, and you can compare the results to select the best material for your design. Otherwise, if anyone is pursuing his research for developing the material for manufacturing a DC machine, then he can add that material in the library. So here are the options like view or edit material or add material. But whenever you are going to add the material, you need to go through this different parameter information. So you before adding the material, make sure that you should have the information of that material in the as per the available list, like name, location, origin, type, relative permeability of the material, bulk conductivity, magnetic coercivity, core loss, thermal conductivity, then mass density, specific heat, etc. Okay, and once you are having that material, you can add that material here. Okay, so right now we have selected the frame size material like so. Okay, here just we'll select the steel 1008 material. Okay, then pole type. So pole type is again type of the stator pole. Here you are having the different geometries. You can select the geometry. Here I have selected the first geometry. So you can go through the design parameters or design diagram. Then pole length. What is the meaning of pole length? Length of the stator main pole. So here I have given the input as 406 mm. Then pole stacking factor, that is stacking factor of the stator main pole. So here stacking factor value is less than 1. Here I have selected the 0.97. Again pole material. For the pole material also the same procedure similar to the frame material. You can select any material from the material library, and otherwise you can check the performance of the machine by selecting the different material for the pole. Otherwise you can add your another material as per your design requirement. If you are going to do the project on developing the material for the machine, okay, then we'll enter OK. Then press board thickness. What is the meaning of press board thickness? That is thickness of the pole press board. It is, I have selected it as 10 mm. Okay. Then magnetic press board, if you want you can check it, otherwise you can keep it as unchecked. Then once you given the inputs for all parameters which are needed to make the stator design, then you can enter the apply button and enter OK, so that stator geometry will be available. Then under the stator there is pole. So we have selected this pole material, pole as geometry 1. That's why that geometry is available here. Then I double click on this pole. The meaning for each parameter. See here, in the diagram, the parameter information is given, like this is the BM, this is the P2, this is the P3, this is G minimum. So meaning of that parameter and along with parameter short name is given here, but you need to give the input for your machine geometry. So here, for example, D minimum. So what is the meaning of D minimum? Inner diameter at pole center, like rotor diameter plus 2 into G minimum. So that D minimum value is given here 424.9 mm. Again here you can select the unit as per your requirement. Then second one is the D max. What is the meaning of D max? Diameter of the pole tip, or you can calculate by the formula rotor diameter plus 2 into G max. So here they have given these values as 430.7 mm. Then BP0. What is the meaning of BP0? Diameter at pole tip or rotor diameter plus 2 into G max. So here we have given the value as 153.52 mm. Then BP1. What is the meaning of BP1? Pole tip width. So here the pole tip width is 219.2 mm. Then BP2. What is the meaning of BP2? Maximum pole shoe width. So here also we have given it as 219.2 mm. And BP3, for clear idea you can go through this diagram also. So this is you can see the BP2, BP3 value. Then this is BP1 value. So BP3 value, what is the meaning of BP3? The minimum pole shoe width. So here we have again selected as 21.2 mm. Then HP. So what is the meaning of HP? Pole shoe height. So here pole shoe height we have given as 6 mm. Then BM means pole body width. So again I request all of you to go through this diagram so that you will get the idea about each meaning of each parameter. Here also it is 180 mm. Okay, then I enter OK. So we have given the inputs related to the pole. Then what is the next parameter? Field. So just I double click on the field. So it will ask for a different design parameter input. First one, shoe insulation. So what is the meaning of shoe insulation? Thickness of the insulation under pole shoe. So here we have considered that thickness as 0 mm. Then pole insulation, that is thickness of the insulation at pole body side. Here also we have selected or we have given the input as 0 mm. Then winding clearance, that is minimum gap between two field winding or minimum gap between a field winding and commutating winding. So here we have considered that gap as 10 mm. Then winding insulation, that is insulation thickness between the shunt winding and the series winding. So that thickness is also we have considered 0 mm. Then compound exciting mode. Compound exciting mode. What is the meaning of this? That is cumulative exciting or differential exciting of the series winding to the shunt winding. So here we have the options of cumulative winding and differential winding. So for this machine we have selected the cumulative winding. Okay, then we enter the OK button. So we have given the inputs related to the field. Now when we enter or press on this plus button, then it will ask for the shunt winding details. So when we double click on the shunt, then there are the options like winding type. So here if we click on the winding type, you are having the different options like round winding, cylindrical winding, edge winding, etc. Okay, so here we have selected the edge wise winding, so just enter the OK. Then parallel branches. So what the meaning of parallel branches? Number of parallel branches, those we have given as an input 1. Then conductors per pole, that is number of conductors per pole. Like for it, you need to select 0 for auto design. Then odd number stands for the case the input and the output leads are in different slides. So here we have selected the conductor per slots like 91. That actually this number of conductors, then wire size, it will depend on the your design and the current which will flow through that winding. So of course your selected winding should be capable to carry that current which will flow through the because of the machine. Then wire wrap. What is the meaning of wire wrap? Double side wire wrap thickness, which is also 0 for auto pickup design in the wire library. Then interturn insulation. What is the meaning of interturn insulation? Thickness of the interturn insulation of edge-wise winding. So here we have selected the edge-wise coil. That's why it will ask. Here we have given that value as 0 mm. Sorry, interturn insulation we have given the 0.2 mm. Then wire size. Here if you double click on this, you are having the list of the different wires. Okay, in which you can select the wire width. Like for this purpose we have given the as 35.5. Okay, we have selected this wire. And wire thickness. Here also you are having the different options. You can select the wires as per the current capacity of your machine. Here we have given this 1.6. Okay. Then unit system is mm. Then we'll enter OK. That means you can select the wire size as per your design from the available library. Then axial clearance. What is the meaning of axial clearance? Axial gap between the field winding and pole body or inner coil. So that axial clearance is 5 mm. Then limited cross width. What is the meaning of limited cross width? That is limited cross section width for winding design or arrangement, and it is 0 for available maximum area. So we have selected here 0 mm. Then limited cross height. What is the meaning of it? Limited cross section height for winding design or arrangement, and it is also 0 for available maximum area. So we have given the input here 0. You can change as per your design requirement or design inputs. Then winding fillet. So limit it. What is the meaning of it? That is limited cross section height for the winding design or arrangement. It is also 0 for maximum available area. So here we have selected it as 0. Then enter apply button and OK. Don't forget to press that apply button, otherwise your design inputs will not be considered. So we have covered up to the shunt winding. Then regarding the commutating, if you double click on it, then it will ask for the pole width, that is width of the commutating pole. So here we have given that input as 38 mm. Then pole height. What is the meaning of pole height? Height of the commutating pole. So that height of the commutating pole is 100 mm. Here pole length, that is length of the commutating pole. We have selected that length of the commutating pole as 457 mm. Then shoe width, that is shoe width of the commutating pole, that is we have selected as 29 mm. Sorry, 29 mm for this case. Then shoe height. What is the meaning of shoe height? Shoe height of the commutating pole. So that is 11 mm for this case. Then second air gap, that is length of the second air gap between the commutating pole and the frame, that is 0 mm for this case. Then pole stacking. What is the meaning of pole stacking? That is stacking factor of the commutating pole. Here we have considered stacking factor as 0.925 mm. Then pole material, that is steel type of the commutating pole. Here also you are having the material library. If you double click on it, we have selected this M19_24G material. But here also again the material library is available. The information is given in terms of the name, location, origin, type, relative permeability, bulk conductivity, magnetic coercivity, then core loss, thermal conductivity, mass density, specific heat, etc. Here also you are having the arrangement of your edit material. You can select the different material. You can compare the result and select the best material for your design. Otherwise, you can add an additional material from your side by importing the information as per the list which we have discussed recently, like name, location, design, etc. And you can upload that material. You can select that material, and you can check the performance of the machine before making the hardware model. Okay, so I enter the OK. So we have selected the pole material. Next point is pole insulation. That is steel type of the thickness of the insulation at the pole body side. So that we have selected as 2 mm. So with this we have given the inputs related to the commutator part. Then enter, apply, and OK. And last part of the machine is shaft. So here if you want, then you can select the magnetic shaft. The shaft is made up of the magnetic material, so you can check it. Or no fan, that is no ventilation fan, if it is not needed, you can check it here. Then fan diameter, that is outer diameter of the ventilation fan. So here we have given that outer diameter of the ventilation fan as 400 mm. Then blade width, that is blade width of the ventilation fan. Here we have given that equals 20 mm. Then we will enter the OK. Okay, so thus we have given all the inputs which are needed to make the geometry of this machine, DC machine. Okay, now what is the next step? Once we have given the inputs to make the geometry of the machine, then we need to analyze your design. So for that purpose, here on analysis you can add the solution setup. Here I have already added the solution setup, and in case of the solution setup, actually you need to give the input of the main technical specification of the machine. Like here, operational type is motor, because we know that the DC machine means it may be the motor or generator. But here you can select the what is the performance you needed. Suppose here we are going to demonstrate the DC motor. That's why I have selected the motor. If you want to demonstrate the DC generator, then you can use to select the operational type as generator. Then load type of, what is the meaning of load type? That is mechanical load type. I have selected the constant power, but you are having the options like you can select constant speed application, constant power, constant torque, linear torque, fan load. So according to the application of your machine for which you are going to design. Then a rated output, that is rated mechanical or electrical output power. So here we have selected the 500 kilowatt motor. So here it is 500,000. Okay. Then rated voltage, that is applied or output rated line to line AC, RMS or DC voltage of the machine. Here that voltage is 580 volt. Then rated speed, so given rated speed of the machine we have already given as an input previously. So here is 1080.1 RPM. And operating temperature at which you want to check the performance of this machine is 115 mm. So here this temperature also you can select as per the environment in which you are going to use that machine for the particular application. Okay, then enter the apply and OK. So we have given we have set up the analysis. We have completed the analysis setup for the machine. Now we need to analyze the machine. For that purpose, just right click on the analysis and then enter add solution setup. Okay, so in case of the add solutions, sorry, we have already added the solution, so just need to analyze the circuit. For that purpose, just I will right click on the analysis, and then I will select analyze all, so that the simulation of the your design is started. Okay, and that progress is shown here, like show progress, for which under the view option you need to select the progress button or progress option, so that here the progress option will be available. This green color indicates that much percentage of the simulation is completed. Okay, and once you click on here, then it will show normal completion of the simulation on server. That means your simulation is completed without any error. But if there is any error, like if you select the any other material, then here, like in stator, suppose right now I have selected, but what is the material I have selected for the stator? Steel 1008. But if I select the any other material, then it will show that stator is error will be shown by red cross mark. Then the parameters under which this error is available, and solder lead free SN35AG 0.7 cu is not steel type, because for the stator design we need to select the steel material, but the material which you have selected is not steel type material. That is the error is available. That means if you do any mistake which is not within the acceptable limit, or which is not as per the standard design for that machine, then it will be shown, or it will be shown like with error here. Then you need to rectify that error, and then again you need to analyze the circuit. Okay, that means under the analysis, in this analysis step, you will get idea whether your design is as per the design standard or not, and if there is any mistake, then that mistake will be shown here, and that mistake you need to rectify, and then you need to proceed further. Okay, now for this case we have simulated our design with no error. Then what is the next step? Then you need to validate your design. So if you click on this validate option, validate the design, then see all the design parameters are shown by green tick mark. That means your design is validated. But if there is any error in the particular part, then it will shown by the red cross mark. For example, the machine which we have selected previously here as a new project, here we have not given any input, and under such condition, if we need to select this project. Under such condition, if I am going to validate the design, then it will show that design settings are correct, optometrics are correct, but machine parameter input which we have given, those are not validated, and such not validated parameters will be shown by the cross mark. Okay, so you need to rectify those technical parameters and make sure that before going through the result sheet, your design should be validated. Then only you need to proceed further. Okay, so for our this project under consideration for this video session, so our design is validated. So now what we'll do, we'll go through the result sheet. So for that purpose we have completed the analysis. So if you right click on the analysis, sorry, if you right click on the setup option, then there are different options like properties, disable setup, analyze, submit job, create quick report, performance, design sheet, curves, then export, create Maxwell design, create iSpeak design. So here we'll go through the design sheet. So once we click on the design sheet, the entire design sheet along with its performance of this machine will be available here. So this is the most important point as an output for our machine. So we will get the entire design sheet of the machine. So which information available under this? So under the general data, information like machine type, rated output power in kilowatt, rated voltage, number of poles, given rated speed, frictional loss, windage loss, type of load, operating temperature, field exciting type, exciting voltage, then determined by given rated speed. That will be available here, that information. Then under the rotor data, you will get the information about the rotor data like outer diameter of the rotor, inner diameter of the rotor, number of rotor slots, type of the rotor slots. Then in case of the rotor slots, the information about different parameters like HS0, HS1, HS2, BS1, BS2. Then top tooth width in mm, then bottom tooth width in mm, skew width, that is number of slots, lamination of the sector, then length of the rotor core in mm, stacking factor of the rotor core, type of the steel which we have used, like we have selected the M19_20 material, then press board thickness, magnetic press board, magnetic shaft, then bend type, number of holes per row, then inner hole diameter mm, outer hole diameter in mm, then inner hole location, outer hole location, number of branding slots. So this is the information. Then apart from that, there is information available about the armature winding, like type of the armature winding, like we have selected lap winding, the number of virtual slots per slot, number of conductors per slot, multiplex numbers, coil pitch, like virtual slots, number of wires per conductor in width direction, then in thickness direction, wire width in mm, wire thickness, wire wrap thickness mm, number of parallel branches, then wire bridge thickness, liner thickness, end clearance in mm, end length adjustment in mm, then layer insulation, bottom insulation mm, coil wrap mm, then base end inner radius. Okay, then top end inner radius, virtual coil arrange direction, then wire wrap in slot, coil half turn. Okay, then information is also available about the stator pole, in which information like frame outer diameter in mm, frame overall width, then frame thickness, frame length, frame material, then pole length, pole stacking factor, pole material, pole press board thickness, then magnetic press board, then pole type, main pole dimensions, then geometric pole impedance, computated field impedance. So this information will be available. Then information related to the field winding, like pole insulation, shoes insulation, overall width, overall height, winding clearance, winding insulation, then series winding width ratio, shunt winding type, shunt branches, shunt turns per pole, shunt wires per conductor, shunt wires width, then shunt wire thickness, then shunt interturn insulation, shunt coil half turn length, shunt fillet, shunt maximum width, shunt maximum height, shunt minimum width, then shunt minimum height, then shunt winding arrangement, maximum number of turns per pole. So this information is available. Then regarding the commutating pole and the winding, so all the information is available in the design sheet, like related to the commutating pole and winding, commutating pole width, pole height, pole length, pole shoe weight, shoe height, then shoe length, air gap, second air gap, pole insulation, shoe insulation, overall width, overall height, pole stacking factor, pole material, then commutating winding type, then commutating branches, turn per pole, wire per conductor, wire weight, wire thickness, interturn insulation, coil half turn length, then commutating fillet, then commutating maximum weight, maximum height, then commutating winding arrangement, maximum number of turns per pole. So this information is available. Then regarding the commutator and brush data, type of the commutator like cylindrical, commutator diameter, length, insulation, then brush width, brush length, brush pairs, brush displacement, brush drop, then press per unit area, frictional coefficient, then fan outer diameter, fan blade. So this information is available. Then related to the material consumption. So this is the most important point. So till now we have discussed about the different design parameters. But whenever you are going to make the hardware model of this motor, then material consumption information is available, from which you can that machine information is given in terms of the weight, material with weight, and you can compare. You can go through the current rates of that material in the market, and according to that, you can estimate the cost which is required or the material consumption as well as the material cost which is needed to make the hardware model of this motor. So under the material consumption, like copper wire density in kg per meter cube, armature core steel density kg per meter cube, then stator core steel density in kg per meter cube, stator frame steel density kg per meter cube, commutating pole steel density in kg per meter cube. So this information is available. Then armature copper in kg, shunt copper weight in kg, series copper weight in kg, compensative copper weight kg, then armature copper weight kg, then armature core steel weight in kg, stator pole steel weight in kg, stator frame steel weight in kg, commutating pole steel weight in kg, then total net weight in kg, then armature core steel consumption in kg, then stator pole steel consumption in kg. That means total copper material, steel material, that weight along with the details of the part of the motor for which that material is needed, that list will be available. Then armature core steel consumption in kg, stator pole steel consumption in kg. So you will get idea about weight of the material required for the different part. You can go through the current rate in the market and you can estimate the cost. Then non-saturated parameters. So what is the meaning of non-saturated parameters? Like armature winding resistance in ohm, then armature winding resistance at 20 degrees Celsius, armature leakage inductance in Henry, armature self-inductance in Henry, shunt winding resistance, then shunt winding resistance at 20 degrees Celsius, shunt leakage inductance, shunt self-inductance, rotating voltage coefficient, then commutating winding resistance at 20 degrees Celsius, commutating leakage inductance, commutating self-inductance, mutual inductance. So this information is available. Then now regarding the performance, no load operation data of the motor, like air gap flux density BG0 in Tesla, rotor teeth flux density, then rotor yoke flux density BC0, then stator pole flux density BN0, stator yoke flux density BY0. So another beauty of this software is that you can do your magnetic study of the machine in detail with the help of this software. Then air gap ampere turns 80 G0, rotor teeth ampere turns, then rotor yoke ampere turns, stator pole ampere turns, stator yoke ampere turns, total ampere turns 80, then no load excitation current, correction factor for the magnetic circuit length of the rotor yoke, correction factor for the magnetic circuit length of the stator yoke, no load saturation factor, no load leakage flux factor, then no load input current, no load armature power, no load input power, no load speed, then no load mechanical loss, no load core loss, no load exciting loss, then other losses at no load. That means all these informations related to the no load performance of the machines is available under this design sheet. Then full load operation data, like in this you will get the idea about the rated armature current, then armature input power, total input power, then what is the efficiency of this machine. Right now don't go through the actual values, just the main purpose of this video is to give the demonstration of this machine, but as per your requirement you can give the input and you can improve the performance of the machine. Then rated speed of the machine, rated torque, armature copper loss rate, and then commutating copper loss, brush voltage drop, then mechanical loss, core loss, exciting copper loss, additional loss, total loss. So this information is available. Apart from that, armature thermal load, specific electric loading, armature current density, commutator current density, shunt winding current density, this information is available. Then other operational data like locked rotor torque, locked rotor current, maximum output power, speed and maximum output. So this information is available. Then transient FEA, that is finite elements analysis input data, is available. Like for armature winding, number of turns 150, parallel branches 4, thermal resistance, end leakage inductance in Henry. For one armature coil, number of turns, parallel branches, thermal resistance, end leakage inductance. For shunt field winding, number of turns, then parallel branches, terminal resistance, end leakage inductance. For commutating winding, number of turns, parallel branches, terminal resistance, end leakage inductance. Then 2D equivalent value. For the 2D model, what will be the equivalent values? Like equivalent model depth, equivalent status, equivalent rotor stacking factor, equivalent pole stacking factor, equivalent frame stacking factor, then equivalent commutating stacking factor, then mechanical data like estimated rotor inertia, rated speed. So this information is available. So that means you will, after giving the certain inputs as an initial requirement of the machine, you can give the input, And as per your geometry, entire details of the motor along with its magnetic magnetic study parameters, then performance under the no load condition, full load condition, material consumption, that entire information you will get, as well as you will get idea about no load and full load operational data or operational performance of the machine. Then regarding the performance of the machine, till now we have discussed the entire design sheet in detail. But if you are interested in the particular parameter, you can select that material, that parameter only, and you will get the specific information related to that parameter, like commutating winding, then API input data, then material consumption. You are interested in material consumption only, you can select the material consumption, then no load of magnetic data, then other operational data, rated operation. So whatever the details we have seen in the detailed design sheet, those here you can select for particular part or particular point only, like rated thermal load data, rotor slot, then rotor winding, shunt winding, then unsaturated parameters. Means you will get the detailed design details. Related to the particular point only. Now regarding the curves, what is the conventional method? We develop the hardware model of the motor, then we do the testing of the motor, we do the different tests, and then we draw the performance curves. But here under this RMXprt tool, you are having the possibility to check the performance curves of some motor for the selected design. Like here, we click on the efficiency versus armature current graph, then that graph or curve is available. Then what type of information you will get? You will get the information about speed versus armature current graph, then power versus armature current graph, then torque versus armature current graph, then no load voltage versus exciting current at rated speed, then air gap flux density at no load, then air gap parameters at no load, and induced coil voltages at the rated speed. So here you will get the detailed idea about the performance curves of the machine. So this is the information you will get as an output by this RMXprt design or analysis in terms of the analysis result. So you can continue your research by checking the performance of the machine, then by selecting the different materials, then you can easily import that information also. For example, suppose you need to you are interested in the design sheet, then just copy this design sheet and paste in the Word file. It is easily available. Regarding the curves, here if you right click and click on the copy bitmap image, then just paste in the Word file, so that image is available for your research paper writing purpose or for your project report purpose. Okay. Now apart from that, here you can go through the create quick report option. Here you can select the particular parameter, like suppose angular speed, and enter OK. Then that angular speed graph is available. So whatever the parameters you need, interested in the particular parameter, don't need to follow the each procedure every time. Once you analyze your design, then different options are available. So accordingly you can directly select. Then apart from that, if you are interested in the curves or performance curve or design sheet, then you can select accordingly. And another point in this case, see, till now we have discussed only related to the design or machine geometry, but we know that the dry circuit will be get completed only when we design or we are having the idea about the supply part of the machines also, like the converter circuit or controller circuit, etc. For that purpose, just I am giving the idea that here in RMXprt you can play with the design geometry parameters only. But if you are interested in, and for that purpose, the by default circuit of the supply circuit or converter and control circuit will be available. But if you are interested to do the changes in the converter and controller part, for that purpose you need to work in the ANSYS Simplorer part. Okay, for that purpose you need to work on the ANSYS Simplorer, that is insert Simplorer design, and you can make your own design. Okay, then related to the conversion of this model, you can directly convert this model into the Maxwell 2D or Maxwell 3D design. So for that purpose, what you need to do, just right click on the setup, then enter on the create Maxwell design. Then there are options like create Maxwell 2D design, Maxwell 3D design, then setup and enter OK, so that design will be converted into the Maxwell 2D or Maxwell 3D parameter. So for example, I have to convert this design into the Maxwell 2D design. I will enter Maxwell 2D design and I will enter OK. Then it will take time to convert this design into the Maxwell 2D or 3D parameter, but your available design will be directly converted into the Maxwell and 2D and 3D design. Okay, and those who want to do the research related to this, what you need to do, you can continue your research work, but if you want to check the performance of this machine for the particular application, like for the electric vehicle application, then you need to connect the battery, then you need to connect the variable load, or you want to work on the converter and controller part. Then for that purpose you can convert this RMXprt design into the Maxwell Simplorer, and from Simplorer you can connect that Simplorer with the MATLAB to conduct the other research activities or to check the performance of this machine for the different conditions. So whenever we are going to convert this design into the Maxwell 2D design, this circuit, that is supply part circuit, is available here. So converter and controller part will be shown here once you convert this design into the Maxwell 2D design. And this is the by default part related to the converter and controller part is available, for which we have checked our design. But if you are having the idea, or if you are interested to know more about this supply part available for this machine while checking the performance, then you need to convert this design at least into the Maxwell 2D design. And under the Maxwell 2D design, then you can go through the supply circuit, that is under the DC motor C, Max circuit 1. Then this model is totally get converted into the Maxwell 2D design. I will show what is the default converter and controller part circuit is available for this design. So you will get the idea from this part only. But those who are interested in the design and simulation part, you can play with RMXprt tool only, and you will get the idea about performance of the machine. But for the project purpose or for the research paper, if you are interested to know about what is the supply circuit which is available for this machine, then just convert it into the Maxwell 2D design. See, in case of the Maxwell, once you convert this model into the Maxwell 2D or Maxwell 3D, then again you can simulate that Maxwell 2D and 3D design parameters. But for that purpose, you need to do the excitation, you need to select the boundaries of this machine, you need to select the mesh operation of the machine. So for the 2D and 3D model analysis purpose, I have created the separate video under this channel only, in which I have demonstrated the induction machine Maxwell 2D and 3D design parameters. You can go through that videos, as well as for the switch reluctance motor I have shown the variation of the flux density, variation of the magnetic field strength, that animation, which is also available under this channel. So those who have not subscribed to this channel, I request all of you, please subscribe this channel so that you will get the idea about latest videos uploaded from me. Okay, so once now this design is converted into the Maxwell 2D design. So for this 2D design is available for the hub portion only. For making it complete model, you need to do the certain design changes, which also I have explained under the separate video, that is 2D and 3D model analysis of the induction motor. You can go through that video. The settings will be same for the different machines. Now once we convert this model into the 2D, then if we double click on the max circuit, then this circuit is available. This is the supply circuit for your machine. Okay, just I am giving the information. If anyone interested to know about this for your project report or research paper, then you will get that idea here. That means by default through this circuit the supply will be available, and for as per this supply circuit you can check the performance of the machine here. So whatever the design sheet which we have got, that design sheet is the machine performance is checked by the converter and control circuit which is shown in the under the max circuit. Okay, thus the use of this ANSYS RMXprt tool is to design and simulate the machine before checking the performance of the machine. Before making the hardware model of the machine. As well as you can convert this design into the Maxwell 2D model. Then you can convert this design into the Maxwell 3D model. So for the Maxwell 3D model also same procedure, that is go to the setup, then create Maxwell design, then under this select the option of Maxwell 3D design, and then if enter OK, then Maxwell 3D design model will be available. Okay, for example, suppose I will show here that just go to the create design, select the Maxwell 3D design and enter OK, then Maxwell 3D design model will be get converted. It also takes time, but make sure that the Maxwell 3D model also you can do the analysis of the Maxwell 3D model to get the output parameters like torque, current, induced voltages, flux linkages, etc. But again the procedure is same, that you need to select the boundaries, excitation, parameters, then mesh operations for the design. And for this purpose also I have uploaded the video for induction machine in detail, that is analysis 3D model analysis of the machine. Okay, so you can go through that. So that's in short, with the help of this software you can first of all, if you are I request you make your own theoretical design so that all the parameters with you, then can select the inside RMXprt design, select the type of machine, give the design parameters as an input to make the geometry of the machine, then analyze your machine, then validate your design. If the design is not validated, go through the error, rectify the error, and then again validate your design. Then once analysis get completed, then we can go through the total design sheet, then performance curves of the machine, then you can go through the quick report, then you can convert this design into the Maxwell 2D and Maxwell 3D model. For by default it will be get converted into the 1/4 portion or half portion through the certain settings. You can go through the, you can make your entire model Maxwell 3D model, but for that purpose again the information about the setting, information about the analysis of the 2D model and 3D model, I have created the separate videos which is available under this channel only. So again I request those who have not subscribed to this channel, please do subscribe this channel so that it will motivate me to create the different videos. Okay, so right now we are converting into the Maxwell 3D model, that's why it will take time, but the step by step that model is getting converted. That is the beauty is that we can directly convert RMXprt model into the Maxwell 2D or Maxwell 3D design. So right now it is available in the Maxwell 3D design, but it is again available for the 1/4 portion only. But if you are you want to convert into the full model, then also through the certain design settings you can convert this model into the full model. Okay, then under the Maxwell 3D design also you can check the performance of the machine for different parameters like torque, then currents, induced voltages, flux linkages, field overlays, for which we need to do the we need to select the boundaries, then we need to do the excitation, then we need to select the mesh operation parameters, for which I have uploaded the separate video. Okay, so I think it will take time to convert into the Maxwell 3D model. So you are having a huge opportunities to play with this software and make your research. Like you can select the different materials, you can check the performance of the machine for the different materials to select the best one. Then you can change the one parameter. Once your entire design is completed, validated, then you can make the change in particular parameter and you can observe the effect of changing that parameter on the performance of the machine. Okay, so accordingly you can make the changes in the geometry and you can prepare your report. Then under the Maxwell 3D design, now this model is get completed. See, this half portion of the model is get completed. You can make your full model also. So this is the Maxwell 3D model is available. We have obtained from the RMXprt design only. Then we have obtained the Maxwell 2D design model from the RMXprt design only. That is half portion. Then we'll get idea about the supply circuit which is available for your machine, and in RMXprt design you are having the idea about detailed DC machines, technical parameters, its results, etc. I hope this video is helpful for your research work. But apart from that, if you are having any query, you can comment in the comment box, and don't forget to subscribe this channel. Okay, thank you all of you. Take care.